Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to introduce another scenario. So we already went through a pretty simple scenario where a user had a bad password and that led to a breach on a Linux system. And in this case, what we're going to do is we're going to step through a little bit more of an advanced scenario, and this will lead us to some things that we haven't done much of so far, such as network forensics and also a little bit of reverse engineering of some malware. Here I have our test system, and what I've already done is I've gone ahead and I've done a memory dump, and I've used dcfldd to get a file system image. Recall that dcfldd allows you to actually take an image on a running system, which is normally not ideal, but in this case, that's what I did. And now I have a system that's running. So if I look at the system and I do something such as an nmap, I will notice some oddities. Also, as before, you might see that it'll pop up a message every once in a while saying, hey, there's some system problems here. And unlike Windows, where everyone says, yeah, of course there's problems because it's Windows, Linux systems, people tend to get a little bit more suspicious. So I'm just going to go ahead and run an nmap. So you can see that this computer is running an FTP server, which is correct. It's supposed to. SSH. It also runs a web server. This looks a little suspicious, as does this guy here. So it looks like something unexpected is going on. I've talked to the system administrators and they told me that yes, in fact, there are no services that are supposed to be using these particular ports. One thing that we're going to do is, as soon as we detected that there was something funny happening, one of the system administrators decided to go ahead and run snort and to also do a packet dump. And I'll run the snort help, and it will tell me things like what interface do you want to capture on, etc. So I want to listen on my ETH1 interface. I will log to a dump file everything that's going through here. So we'll generate a little bit of traffic here from our attacker machine, and this will help us to analyze what's been going on with our attacker. Now, as a double check, we will also run nmap against our target system from our forensics workstation. And of course, this allows us to see things even if everything has been all Trojaned on the target system. So I'll just run a quick nmap scan here. We'll verify that we get the same results. And sure enough, we have the same two suspicious processes at 7777 and 44,965. So that's something we definitely want to look into. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon. Hello, welcome to Linux Forensics here at Pentester Academy. In this video, we're going to continue to investigate our second subject system, and in particular, I wanted to run through some of those scripts that we wrote in order to determine whether or not there was an incident at all. So I'm already here on my subject system. In this case, it's running in a virtual machine. So remember my tip. If you're using a virtual machine, you probably want to stick with a USB 2 drive. But if you're working on a real machine, you probably want to use a USB 3 drive. So here I will say please pass through this Lexar thumb drive. And here we go. It's been mounted. And now if I go to a terminal, come root, and I will go to the appropriate place. I will load my known good binaries, like so. I will first run bin bash. And now I'm going to set my paths correctly. And now I need to set up my library appropriately. Do a quick check. Everything seems to be working correctly. And now I can set up my environment by doing source.setup client and giving it the correct address for my forensics workstation. That is done. And now on my forensics workstation, I will need to set up my environment. I need to set up my listener. And recall that we had a script for that. We have a script for everything, right? So if I go ahead and look at my shell scripts, I have one to start a case. Recall that the start case will start up the listeners for me. So all I need to do is, again, I probably need a root shell, start a case, and if I don't tell it anything, it gives me the usage. So I'll go ahead and say this will be case PAS2-0715. And now if I do an nmap, I should see some new listeners right here. So that's all good. I'm ready to receive. And I will just go ahead and use that one big script, initial scan. And that took just a few seconds. I can go back here. And sure enough, I have a new folder that's been created. And I have my log file. I'm going to go ahead and bring it up. And here you can see what version we're running. We can see the date and time information to detect any kind of skew. We can see what is running on the system, etc. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, I want to investigate some of the services we discovered when doing live analysis on our second subject system. So as a reminder, let's go ahead and I'm going to run an nmap on this system. And we had previously discovered that there were some processes running on port 7777 and also on port 44965. Again, remember that we've already made an image of the system, so now we're not corrupting anything. We're just having a look and seeing if it might be a little easier to figure out what's going on with some of these things before we actually shut it down. So let's start with port 7777. So I'm going to go ahead and telnet, and it's asking me for a password. So something is running that immediately came up and asked me for a password. And it tells me that that was not the correct password. So some unknown entity is running on this port. So what about the other port? Well, let's have a look there. Let's do a quick banner grab. And now it comes up and it says, hey, I am SSH 2.0. So this guy claims that he is some sort of server, some sort of SSH server. And we can verify this if I go ahead and I say I want to SSH using port 44965, and I want to be user John at this address. Sure enough, it came up and it said, are you sure you want to connect? Sure. And now it's asking me for this user's password. And apparently that was not the correct password. So at any rate, what we've done is we've managed to show that we are running an SSH server. It would appear that this SSH server is not necessarily running with the same user base as the machine overall. And you could verify this through a couple of different means, but this at least gives us a starting point and things that we want to look at a little bit further. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon. Hello, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to delve a little bit deeper into some of the processes that looked a little bit suspicious in our second subject for this course. So we noticed a few things that were running, and we ran some of the PS commands, namely PS list and also PS AUX and volatility. And as before, we will use our alias. So as a reminder, I've set up this alias to avoid having to type this obnoxious string all the time, and quite likely fat fingering it most of the time as well. So if I use my alias, now I'm going to use the Linux PS tree command, and I'm going to pipe that to more. So it's off and running, and I see on my first screen nothing terribly interesting. And then on my second screen, I notice I have SSHD running, and it's running SSHD, which runs SSHD, which runs bash, which runs su, which runs bash, which runs insert module. So that's not necessarily all that suspicious when you realize that that process is most likely the process I used for dumping the RAM. However, a little bit further down, I see this guy, drop bear. And we'll have to investigate this guy and see exactly what he is. So he's on process 1284, so you probably want to jot that down. And looking through here, once again, we see our Apache 2 process that was started as root, which then spawned a bunch of other processes that are not running as root. So that's a good thing. We see our Xingxi bind shell process on ID 8540. And notice that when I look at the tree view, I can see very clearly that this spawned a shell, which spawned Python, which spawned a bash shell. So I have multiple levels of strangeness here, where I have shells that are creating shells that are creating shells. And that is pretty much that. So we were able to find a couple of suspicious items by running PS tree. Now I could get a little bit more information about some of these if I want to drill down, and I will use Linux PS env to get the process environment, and I'm going to give it -p, and we'll start with that drop bear process 1284. And you can see this environment, and it says run level equals 2, upstart job, etc. So what this tells me is that this drop bear process is being automatically started in run levels 2 and higher. So someone has installed something, and it wasn't one of the system administrators that's being run every time the system gets booted. So what about some of these other processes? I might have a look at some of these SSH processes. So I'll rerun my command. And this time I'm going to run it for 7621. And I see it's being run user sbin Nothing terribly exciting there. 7681. Something similar. What about this process where someone ran su mysql? I believe it was user 1001. Let's see if there's any other information there that might be interesting. Process ID was 8019. And here I have quite a bit more information, and I can see very clearly that the login was Michael. So this was done from user 1001, who is also Michael. And here I can see that this was done over SSH. So someone logged in as this user and attempted to switch to this bogus MySQL L user. And what else can we find out? Let's have a look at our Xingxi bind shell process. So here, once again, it looks like somebody was logged in, and in fact, the user who was logged in is this bogus MySQL L user. Recall from previous videos that we discovered this bogus user had a home directory of user local MySQL. That's something we probably want to look at later when we start doing some file system analysis. Let's have a look at the bottom process in that chain for the Xingxi bind shell. And here again, it looks very similar. We have the user MySQL L that is running this. Okay, so those are just a quick couple of additional things. And again, as always, we're just constantly adding a little bit of information and a little bit more information to try to put together the pieces of this puzzle and try to figure out what exactly happened on the system. It looks like this Xingxi bind shell is becoming very popular. We've had this rootkit installed on both of our systems so far, and this one seems to have some additional items as well. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to look at some process dumps and maps from those suspicious processes in our second subject, the PAS2 system. So as before, I'm going to use my convenient alias, this guy right here, so that I can avoid typing obnoxiously long commands every time I want to run volatility. So here I have my first command I want to run is linux proc maps, and I want to run it on just a particular process. So we're going to start with our drop bear process, 1284, and we're going to pipe it to more. And here we see the different memory spaces that are being used, and notice that the file that's being referenced here is user include SSL v3 drop bear. Now, if you do a little bit of research on drop bear, what you're going to find out is that drop bear is an SSH server, and it's something that you can easily install and use as a backdoor, which seems to be the case here. Normally you wouldn't expect to run your SSH server on port 44,965. Most people like port 22, for example. So that's our drop bear process. Well, what are some of these other processes that we might want to have a look at? How about our Xingxi bind shell process? So let's have a look at that one. All right, so we can see there's references to bin, Xingxi bind shell, and a couple of C libraries as well. So this might indicate that this is written in C. You have to be careful about making that assumption. Just because it is using libc doesn't necessarily mean that it was written in C or a C-like language. It's not terribly unusual for an assembly programmer to use libc for certain items because some items are just really difficult to use raw assembly for. It's a much easier process to just call a libc function sometimes. Now, if we look at the process at the bottom of that pile from the Xingxi bind shell, we'll see that sure enough, there are references to bash and to things associated with bash. If I look at my process that was used to SU to MySQL, again, I see SU being run. I see a keyring being accessed, which makes sense. It's validating who I am. And there's some other interesting things being run here in this process. So much for process maps. What about process dumps? Well, let's start with our drop bear process. And if I want to dump this process, I have to give it a place. And I will just dump this one to /temp. If I run xxd, you can see here we have the elf signature. We could put this through something like obj dump or readelf, which we'll learn more about in some future videos. For now, I'm just going to go ahead and dump a few of those processes like so. And we will come back to these processes in some future videos. But that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue to look at our second subject, the PAS2 subject, and in particular, we are going to look at the user's bash histories. Now recall from some previous videos that you will store your history in a history file that's normally in your home directory, and this can be changed. You can change how many commands are stored in this file. You can even make it store nothing at all. Some users, in particular the root user, normally doesn't have a history file for security reasons. So getting this information out of memory can be very helpful in reconstructing the history in some cases. So we're going to go ahead and we're going to use our alias. And again, remember that I've set up this alias here in my bash RC file that allows me to more easily run these commands. So the command that I want to start with is called Linux bash, and we'll pipe this to more. All right, so here we see a couple of things. So we have a shell with process ID 7682, and we can see that this user had a look at their bash RC file, and they also changed to the temp directory and did a wget for our rootkit. They then changed to the MySQL user. So we might want to make a note of that. This was originally downloaded into the temp, and it was the user who was logged in into process 7682 that did this. So we can see here in this process, they changed to this user local MySQL directory, which we already know has some bad stuff in it. It's a home directory for this bogus user. And then they ran weevily py, which is a Python script, generate hacked. And what this does is it creates a weevily backdoor, and we'll talk more about that in some future videos. They then created a weevily PHP file, which they copied to var www HTML as index3 PHP. So that's something else we probably want to take a note of, is that weevily has now been installed with the password of hacked, and it's called index3 PHP. They then did an ls, and it looks like they did a wget. It's a little bit curious why they would have done that. And what is quite possibly the case is that because these things occurred within the same second, this obviously doesn't make sense. Why would someone run wget after they had in fact downloaded? But at any rate, what you can see is that this person ran this weevily backdoor, generated a new file with the password of hacked embedded inside of it. Let's see what else they did. Here they extracted it, and we can see that they moved some things from home MySQL to user local MySQL. They also ran the last B command, so they were trying to find failed logins. They ran the last command, and it looks like they've downloaded the RockU password list. So they've been very busy. What other kinds of things did they do? It looks like they've installed Hydra, an online password cracker. They ran an Nmap on a computer in the system. They copied this RockU list to user local MySQL. They checked the home directories, and it looks like here, once again, we have this wget command. So there's a little bit of strangeness here. I don't think they would have downloaded it more than one. Here they're doing an Nmap on the whole network, and we see that they copied the password file. They also apparently changed the mode of the shadow file and then copied it. They ran Hydra against the user Sue with the RockU list against FTP on the local host. Now, this is smart for a couple of reasons. Normally, why would you do online password cracking? You wouldn't. You would try to avoid it. However, the fact that they're on the machine and they can access FTP through the local host is most likely not monitored by any kind of intrusion detection system. So they're essentially going in through the back door, and it's also going to be much faster than it normally would be. So here they're attempting to crack the Sue user's password. We'll have to investigate whether or not they were successful. And it looks like here they're copying the Xingxi Quan files, as we can see there. And what else have they been up to? They make a directory, a hidden directory called .hacked. So we need, again, I would make a note of that. It's probably under user local MySQL. Maybe not. We can always search for that. What else have they done? They extracted Xingxi Quan. They unzipped the Rocky list. Looks like they've installed a few things. They've run a uname, -a command, etc. All right, so here we can see in shell 920, a lot of these things are going on. Now, recall that shell 920, rather shell 9210, is in fact a subprocess of the Xingxi bind shell process. So this makes some sense as to why some of these things are repeated here. And that's pretty much what we find from the bash histories. Now, we can rerun the PAS2 command. It's essentially a customized version of this for bash. So I can run Linux bash env for process 8021, and that will tell me a little bit more about this process, who was running it, etc. And surprise, surprise, MySQL was the user, started out in the John user's home directory. Looks like they were SSHing in from this machine, etc. I can do something similar with the other shell. I'm not going to bother, though, because we've seen that it's all been duplicated because of how this was run. I could run my bash hash as well, and here you can see what was run a few times. Notice that the user ran ls quite a bit, unzipped a few things, etc. So this picture is getting more and more clear as we go through it. We see just a little bit more, just a little bit more. So in this video, we've seen there was another backdoor installed. We've seen a hidden directory that was created, and we even have the password for this backdoor. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to delve a little bit more deeply into the PAS2 system. In particular, we're going to use some of the volatility check functions. So we'll just go through these and see if we find anything. So we'll again use our alias as normal. Now we'll run Linux check AF info as a start, and it found nothing. So other commands that we can run. Let's see if anyone is sharing credentials, and apparently not. So that's another one that returned nothing. That's another one that returned nothing. What about our file operations? Anything funny going on there? And after many minutes of processing, volatility found nothing, at least for this plugin. Let's go ahead and have a look at another plugin. In particular, let's look at the IDT. We'll look at the interrupt table and make sure that there were no issues there. So here we can see that everything was in a similar address space. Nothing suspicious going on here. So let's try another plugin. Let's check for any inline kernel function. So we'll do a Linux check inline kernel. Here, once again, after many minutes, the volatility check plugin found nothing. So we'll try another plugin, and this time we'll run Linux check modules, and we found nothing once again. Now remember, one of the things that an attacker can try to do is they can try to hide a module from certain parts of the operating system. And you might be able to fool some of the operating system. You might be able to Trojan things like LSMod, but you can never fully remove your module from the operating system. Otherwise, it wouldn't be accessible. Another plugin that we can try is Linux check syscall, and this will check and see if the system calls have been redirected to a bad place. Now, many minutes later, we start to see a couple of results. And the first thing you should notice is that, sure enough, one of the 64-bit system calls has been hooked, and it says hooked by Xingxi Quan. So the open function has been hooked. Also, the lstat function has been hooked. And let's see if there are any further hooks. Here's another one, the dupe function, the kill function. Incidentally, it's things like this that can cause a system not to shut down correctly once it's been infected with a rootkit. Another one, get dense, change directory, rename, and remove directory. Also hooked. Now, incidentally, instead of piping this out to more, I could have piped it to grep on the string hooked, and that might make it a little bit easier in order to see where things have been altered. So finally, we did find some alterations, courtesy of volatility. We can now check for any kind of keyboard loggers, and we see the normal stuff here. And let's go ahead and do the other keyboard logger check. And again, we found nothing. So those are some quick checks with volatility check modules. As we can see, we found just a couple of things. Not too much new information here. We already knew that we had the Xingxi Quan rootkit. Naturally, we didn't detect some of the other things, and we'll talk more about that in some future videos as to why we wouldn't expect to have detected them with volatility. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to look at some of the volatility networking commands for our PAS2 system. So the very first one we're going to start with is we're going to do a PAS2, and again we're using our alias as we have done in the past, and we're going to run Linux ifconfig. One of the interesting things that it's telling us here is that we have this guy here, eth1, in promiscuous mode, which is obviously kind of suspicious. So somebody is sniffing traffic on this network. Now, recall that if we run the netstat command, it's going to give you a bunch of output, and you might want to examine TCP, UDP, and Unix sockets separately. So let's go ahead and do that. So here we see right away a couple of interesting things. We have SSH running, which we knew about. We also have this dropbear SSH server running on port 44965, which we talked about previously. So let's see if there's anything else interesting to see here. And sure enough, we also see several things talking on port 7777, and it tells us that those are associated with our Xingxi Quan bind shell. So this is associated with our rootkit. So no new information here. We already knew about this rootkit, but we're just seeing more evidence that shows us that this rootkit exists. And again, it's never bad to have more evidence. Rerunning this for UDP, we see some of the standard processes that are running, and really there's nothing too exciting here. It's all pretty standard stuff. And of course we could rerun this once again for Unix sockets. And here we're going to find a whole bunch of processes. And this might be a little bit harder in order to find anything suspicious, just because there are so many different processes that tend to use these as a means of communication. And really, there's nothing at all suspicious about these particular processes. Now let's check our net filter. And we see that yes, in fact, there is a hook pre-routing table. And we suspect that that's probably related to our Xingxi Quan rootkit. We can also check to see if there's been any modifications made to our ARP table. And everything here looks pretty standard. We can also check for sockets that are operating in promiscuous mode. And we see that Snort is operating in promiscuous mode, not too surprising. And also the DH client processes, one per interface that's using DHCP, are both running in promiscuous mode. So nothing terribly surprising there. Great, so there you have it. That is just a quick run of some of the networking commands of volatility on our PAS2 subject system. So that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to run some file system commands from volatility on our PAS2 subject system. So we're going to start out by using our alias to run the Linux mount command. So here we see a couple of things that were mounted. Nothing too suspicious so far. I can see that someone has mounted VirtualBox guest editions right here. There you have it. Nothing too unusual. All right, so let's go ahead and enumerate over some files. So here we see under our run file system a few things. So we have all of the different user processes, and they each have some files. So we can see here 112 has some upstart processes, 1000 has Unity running, and a few other processes as well. We can see all the devices on that file system. We can see our system file system. And there's really quite a bit of information here to look at. So I'm going to go ahead and stop this. Now, if you're going to do this in part of an actual investigation, you might want to put this out to a file and then search through it. In our case, we're going to see if there's anything related to our drop bear or Xingxi Quan rootkits. We'll pipe this to grep on Xingxi. We see a couple of temporary files and also some files in our bin directory associated with this rootkit. And then under user local MySQL hacked, we see a bunch of other stuff. So it would appear as though a bunch of things have been stored in this user local MySQL file system, but we already knew about that, and we can investigate those a little bit further when we do a full file systems analysis. So what about the drop bear stuff? Let's see if we can find any references to that. So I've gotten one hit so far, And that was it. Just the one hit for that one. Why don't we do something interesting? Let's have a look at the various users' downloads folders. And again, this is something that we could do with the dead file system image analysis as well. And we came up with absolutely nothing, just a listing for John's download directory. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to start to do some file system analysis on our PAS2 image. We've managed to figure out a few things using volatility in the memory image, so now it's time to get serious about figuring out exactly what happened. So we're going to start by mounting our image, and we're going to use our old friend, our mount image Python file, and then we will do a little bit of analysis using standard Linux tools. And now we're mounted. So there's several things that we can do right away. We can look at who has user ID 1001. So we can go to the etc directory and we can grep for 1001 in password. And it tells us that Michael Keaton has that user ID. So Michael Keaton, his account at least, was used at some point in this attack. Now, another thing that we discovered in this analysis of the memory was that there had been a backdoor installed, the Weavely backdoor. One thing we might also want to do is to have a look at the web server logs. And those are, of course, under var log. We're looking at Apache 2. And we see several different kinds of logs. We have our access logs and our error logs. So we might first want to have a look at our error logs to see if there was anything funny going on. And then we might also have a look at our access logs. We see here that there isn't much in our most recent error log. So we'll have a look at the first archive. Now we do see a couple of things that occurred on May 3rd. Right here I see a sig term caught and it was shutting down. Here I see sig term caught and shutting down again, and another sig term. So that's kind of interesting that we have so many sig terms coming through here. And here is another interesting thing. There's an error. It says access denied for root at localhost using password no in MySQL handler PHP, which almost seems to imply that somebody tried to access MySQL via the website unsuccessfully. In fact, what do we see here? We see repeated attempts that also failed. And these are all around the time of our breach, or suspected time of our breach, I should say. Uncaught exception and more access denied messages. So I think it's safe to say that there were quite a few suspicious things that happened all around the same time with this web server. We can, of course, have a look at the access logs and try to correlate them with that approximate time frame. Now these of course are naturally much larger, but you might want to open these into a text editor. So we're going to go ahead and do that. So here we can see all of our access logs, and we can see where everyone was coming from. Now in our case, because this was run in a virtual box, everyone is coming in from the same place. Now one thing that we could do to make this simple is we could search for something like PHP And this will tell us all the times that someone got a PHP web page. This will at least highlight the different things that are being called. Now, one thing I noticed right away is that there is this page, DNS lookup, PHP, that's being called an awful lot. Now, I wouldn't normally expect this page to be called that often, so I might be suspicious. I might say this must be some sort of an attack, and the attacker must think that that particular guy is vulnerable. So again, look at all of these excessive calls to this one page. If we go back to our terminal window, we can use grep, and we can get a little bit more information about this. So I'm going to grep on DNS lookup PHP and access log 1. And this gives me all of those lines. And I'm just going to see how many there are by piping this to word count-L to give me just the number of lines. So this one command was called 51 times, which again is extremely suspicious given that this is not a widely used thing. It's not the main page for this website. So this might be an indication that the website was compromised through this. So one thing you might want to do is come back later and have a look at this particular PHP page and see if it might be subject to some sort of SQL injection, etc. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello, everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, I wanted to walk you through the PHP file that was called repeatedly as we discovered in the previous video. Now, I have to say this is not a course on discovering web vulnerabilities. There are a lot of other great courses here at Pen Tester Academy that you can use for things such as this, but I thought it might be insightful just to give you a little peek into what happened here and why someone might have called this particular file 51 times. The other thing that I have to tell you is that I actually used a vulnerable web application called Matilde in order to do these vulnerabilities. Now, this is an intentionally vulnerable application. However, I did this for convenience and the lessons are still the same. So just because this was intentionally done doesn't mean that programmers don't unintentionally do the exact same thing. So let's have a look at this program, and I've opened it up in Bluefish. You can use whatever your favorite editor might be. Naturally, I've already mounted my subject file system as we did in the previous video. You can see in the comments that this file is subject to command injection, method tampering, cross-site scripting, and HTML injection. Now in particular, we suspect they might have done some command injection because they were able to run some commands on the local system. So if we do a little checking here in the PHP, we will see that this, because it's an example, it does have the ability to enable some protections against command injection, which wasn't done here. And it looks as though target host text is being used as a variable. So we want to look and see where is this being used in our target. So here we can see a report where it just pastes in this, but this next line is the problem. Right here you can see, what are we doing? We're doing a shell exec. So sure enough, they are doing a shell exec and doing an NS lookup on some unauthenticated text. So what do you need to do if you're an attacker? Obviously, all you need to do is append some additional commands to the end of your target, and then you can run them. So unfortunately, we don't have the level of detail here in the logs that shows us every command that was executed, but at least we have somewhat of a clue. And this is definitely a flaw in this website that needs to get fixed. So I might search on this exact string that is put through, and notice here that depending on how you've set the flags, it's going to do a regular expression match, and it will either give you what you matched or it will refuse to run. So if we have a look at this string, target host, you can see here when the form is submitted, this is set, and it may be validated depending on the switches that we have set up in Mutilidae. And here, if it's being validated, you'll see that it first checks to see if it's a IP4 match or a domain name match or an IP6 match. And if none of those return any values, then it says, no, it's not validated. Otherwise, if we're not checking, it just says, sure, it's all good. Also, there's protections against cross-site scripting, which we're not actually using in this particular attack as well. And again, here we have the shell exec that's being executed with NSLOOKUP and this target. So lots of opportunities for someone to do something bad. Again, unfortunately, we don't have all the details in our logs as to exactly what the user entered. And there's no bash history either because there's no interactive shell for this user. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon. Hello, everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to continue our file system analysis of our PAS2 subject system, and in particular, we're going to have a look at some of the MySQL logs, given that we found that there was a web vulnerability that was exploited, and also the fact that there were several MySQL errors reported about the time of that breach. So hopefully we can get a little bit more information by looking at the MySQL logs because, again, the access logs from the web server did not have detailed information that we wanted. I've already mounted up our subject file system using our Python script, and I'm in the var log MySQL directory. If I do an ls, I will see that I have an error log, and I also have a couple of compressed logs. So I'm going to go ahead and look at the start of my error log. I see that this starts on June 20th, which is way past the suspected time of this breach. In particular, it's not anywhere close to the time where I had these errors. So what about these compressed logs? How can I look at those? Well, instead of using something like cat, I can use something called zcat. So I can do a zcat on error log 1 gz, and I'm going to go ahead and pipe that to head just to see where this thing starts. Here again, this log starts on May 4th, a month past the time that I'm interested in. So let's have a look at the second backup. So I will just change this to a 2, and now I see that the second log starts on May 3rd, which is exactly the time that I wanted to investigate. Great. So I can either pick through this manually, or I could use some regular expressions to help me out. And of course, you know what I'm going to do. I'm going to use some regular expressions. Why? Because it's easier and because I can. So let's go ahead and use egrep to point out only the errors in this log on May 3rd. So what I'm going to do is I'm going to repeat this command. Instead of piping it to head, I'm going to pipe it to egrep, and I will egrep on either a line that starts with the timestamp 15:05:03 or that contains error. Either one of those conditions, I want to print it out, and I will pipe that to more. And so here I can see that there are a few things that have come up. So here's my first error that I notice. It says you have an error in your syntax for your SQL statement, and you are trying to alter a table and add a column. So this might indicate someone is trying to do a SQL injection of some sort. It aborted and it shut down. So let's see if anything else happened about that same time. And once again, there was an error and it aborted. And here there's an error saying that something crashed and something needs to be repaired. And once again, it shut down, crashed again, was rechecked. So you can see that there were a couple of strange looking things going on there. So it would appear as though our attacker tried a couple of different things when they were attacking the system. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello, everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue to examine our PAS2 subject system, and in particular, we're going to have a look at this directory that we discovered in some of our earlier investigations that is under user local MySQL. So I've already mounted my system and I've changed to that directory. And if I do an ls-al, I will notice a couple of things. First of all, I will notice that there are a couple of hidden directories. One here called Weavely. We've already discussed the fact that the Weavely backdoor was found on the system. And another one called hack. Now, the first thing I should point out about these two directories is that often, if you have a rootkit that's been installed and you're looking at the live system, these directories might be hidden. However, if you're mounting an image of that file system, you can see them straight away because your forensics workstation doesn't have Trojan binaries or anything like that. So we have a look. Let's look first at Weavely, and we can see that there is a file called Weavely RC, which has a length of 0. So whatever was in there, there's nothing important in there now. So let's have a look at hack. And here I see a couple of interesting things. I see the RockU password list. And again, we did see in previous videos an indication that someone was doing some password cracking, so this makes sense. And I also see a Xingxi Quan rootkit. So if I change to this directory, I can see an install file and a few other things. Now, one thing to keep in mind, because I have mounted this on my forensics workstation, it says that some of these files belong to Phil, which is incorrect. What it really means is that the user has the same user ID as me, so they are most likely the primary or first user on that system. So here we can see various bits of information on our Xingxi Quan rootkit. So it looks like our attacker's been busy. Now, this may have been some of those 51 commands that were executed through our bad DNS lookup PHP file. You don't really know. There's some other ways that you can try to investigate that, and we'll look into those later. So let's go back up to our MySQL directory. I do an ls-al. I'll notice that there are a few other things here as well. Now, notice that there is a bash history file that is owned by root, which is rather interesting. So I'll have to become root in order to see this. And now I can type out this file. And what kind of commands do I see? Well, I see some very telling commands here. Starting at the top, I see that someone used wget to grab the Weavely backdoor. They then untarred it, changed to a directory, and they ran weavely.py. They also installed something called Beautiful Soup. and then they ran weavely, and they ran it with the generate command and hat as a parameter. Now, if you do a little bit of investigation, you do some online searching on Weavely, what you'll find, this is setting up a backdoor, and the password that it's using is called hacked. So hacked is actually the password. We've just discovered that via some simple file system analysis. You see here that they copied this Weavely PHP file into our doc root on the web server as index3 PHP. So that's another good discovery. And it looks like they tried to cover up by moving Weavely to a hidden directory called Weavely. They then ran some nmap commands. They installed Hydra, an online password cracker. They also displayed who is last logged in and any failed login attempts. Seems that they got the RockU password list, and later they unzipped it. They did an ls/home. This was probably an attempt to see what regular users were on the system. They did an nmap to discover what local services were available for attack. They then ran Hydra against the SU account. So this command here says, please run Hydra. SU is the user. The password is a list, RockU, against the localhost FTP service, please. So why would you want to do this? Well, a couple of reasons you might want to do this. FTP is quick, so if you have to run an online password cracker, it's a good choice. Also, running against the local host is extra fast and often not monitored. So it's a very common thing for people not to monitor stuff on the local host. They might have intrusion detection or prevention, but often it is only on external interfaces. Here you can see that they've copied out the password file and the shadow file. They've installed something, probably the Xingxi Quan rootkit, and that's all that we have in their history file. I say that's all that we have, but it's really quite a bit that we've been able to glean from looking at just a couple of files that were hidden away. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello, everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue our file system analysis of the PAS2 subject system. And in this video in particular, what we're going to do is we are going to have a look at the timeline. So we're going to go ahead and use the script that we created many videos back in order to print a timeline for the system. So I've already created the timeline with the other script. And here I'm going to run my print timeline script, and I will pass it the name of my database. And we said that our interesting date was May 3rd, 2015. So that will be my starting point. And I will run this and pass the output to a file. I'll call it ps2-timeline.txt. So I'm going to go ahead and run this query. It's going to ask me for my password to the database. And it will take, as you see, less than 2 seconds to run, which is pretty impressive if you look at the size of this database. So now I'm going to go ahead and bring this up in gedit just to make it simple. And you'll notice that gedit has to think a little while in order to load a file quite this huge. So let's scroll on down till May the 4th, which is, of course, Star Wars Day, right? May the 4th be with you. So here we found the last entries for May 3rd. And what do we see here? We see some changes at the end of the day to index 3. We already discussed this. And this is the Weavely backdoor. We see a few Python modules being called. Now, these are probably being called by an earlier call to a Python module. So notice here, there's a call to beautiful soup that was installed, probably as a requirement for this rootkit. If we go back a little further, we see a bunch of Python functions being called because it was most likely needed in order to install Weavely. There's also some other interesting things, such as fake root that's being accessed. Let's have a look at files from the document root. So I'm going to go ahead and search on var www HTML, and let's see how many hits we get on this search. So we have over 7,000 hits onto our document root. So let's go ahead and we'll use grep to make our lives a little bit easier here. So if we do a grep and we say, I only want things that started with a C for a change in PAS2 timeline text, and we're going to pipe that to things that also contain var www HTML/. And I'll pipe all that to more. This should cut down a lot on our results. So here, once we do that, we can see that we've created some new items. Here, nothing terribly interesting other than the index 2 and index 3. So looks like we need to have a little investigation into that directory. It wasn't just index 3 that was created new, it was index 2 as well. Now let's have a look and do something similar, but now we're going to look at anything under a bin directory. So we see under bin, we have lots of things that were created. In particular, we see stuff from our Xingxi Quan rootkit. We also see something called PW Inspector. Not certain if that's malicious or not. Hydra definitely is malicious, and it was installed at the same time. So that's probably your answer right there as to whether or not that's malicious. We also see a fake root, C++ program, both of them being created in user bin, and nothing else terribly interesting. In particular, everything else seems to have been from well before when our breach occurred. We can do a similar test for sbin, and here once again, nothing too interesting is noted. So we're starting to put together the pieces just a little bit more of what happened and when. So we've been able to narrow it down to the nearest second as to when these breaches started to occur. We certainly have enough evidence to say that there was a breach, and we could start thinking about figuring out who attacked our system. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue to look at our PAS2 subject system, and in particular, we're going to have a look at some of these new HTML or PHP files that have been dropped by our attacker. So we'll start by looking at this file that was called index2.php. Now, if we have a look at this, we're in luck here because the author was nice enough to give us all kinds of documentation. So it says this is a Poison Shell 1.0 by Dottie Hackman 2012, and he even gave us an email address. So here you can see that we have a username and a password which has been encoded not very well. You can tell that they are both probably equal to test from the comments, but you could also check this out. You know that they're the same no matter what they are, just because they have the same value. So here you can see where if everything matches, MD5 of the user that matches what's stored, and the MD5 of the password that also matches what's stored, then you get a new session. So pretty simple. They have a couple of functions that they've defined here. You can see that they're running a MySQL connect, and as with some of the other backdoors and malware that we've encountered thus far, you could certainly do some research online into this poison shell. Here you can see where they're connecting to MySQL and executing a few commands. We have some setup information on a style sheet, and here you can see where they've set up a screen that's supposed to look like a skull as part of this shell. So it's a web shell setup, fairly straightforward if you know PHP and how all of this works. What about the other file? Let's have a look at that one as well. Here is our index 3, our Weavely backdoor that we discovered previously. Now this guy is a little bit more complicated. So you can see that they've made some effort to obfuscate code. You have a bunch of strings that have been set up, and then there's a bunch of functions that are called. So if you step through this, here's what you're going to find. Let's start with this very first string replace. The help in Bluefish here tells me it will search for whatever the first parameter is and replace it with the second parameter in the subject. So it's going to search for n and replace it with nothing in this string. So if you work out what this is going to do, I'll just type it in here real quick. I'm taking out the n's and I'm going to get stir replace. So this is going to become stir replace. So on the next line, I'm calling stir replace again. So it's been hidden, but not very well. And now I'm going to do something similar. I'm going to drop out everything that has SJ in it. So if I do that, I will get BASE64DECODE. So HBH is going to be set equal to base 64 decode. So this was our first item, KH, rather KBH. This was our first item, KH, and here was our second item, HBH. And then on the next line, we are going to set KM equal to CREATE underscore FUNCTION. Create function. Making all of those substitutions, we see that Go is going to be create function with a blank argument, and then we have base 64 decode of stir replace of Q. We'll replace it with nothing, and then we have $IY dot $GN dot $mom dot $SCV, and then we will call go. So we're going to create a function, and then we're going to call go. So let's work from the inside out again, and we're going to take all of the Q's and remove them. So let's go ahead and use a find and replace. We'll search for a Q and replace it with nothing. Now, I'm going to paste these together. So I'll start with this guy, and I'll paste it into a decoder. And we see so far we have the start of a function. I'll go back to my program and see what comes next. What comes next is this guy. Looks like I'm still good here with my function. And then we have mom, and then the last piece. So there you have it. This is our completed function. I can copy this, paste it back in here, and this will show me what I'm creating. All right, so there you have it. After a lot of work, we have completely decoded this guy here. So this is what he's going to do. He's going to decode to this function, and this function immediately gets called. So if you look closely enough at this code, you will see that in fact The password is also embedded in this code. It's just a little bit obscured. So here you can see the HA, and here you can see the rest of it. So hacked is how it all comes together. So even at this level, this code is somewhat obscured. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello, everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to look at some of the packet dumps that were captured after a breach was suspected on the PAS2 subject system. So you called the administrator, you walked him through installing Snort, which he did, and he was actually doing some full packet capture. So this was the John user, and if you look, you will see that sure enough, he has a packet capture here for you. So let's have a look at this in Wireshark and see if, in fact, this is useful. Once again, we've mounted our file system onto our forensics workstation so we can have a look. And naturally, that file system includes this packet capture. So go ahead and bring it up into Wireshark, and we get the standard warning. Don't run Wireshark as root, but if you don't, it's pretty worthless. So probably one of the dumbest warnings ever. All right, so here we can see there's a whole bunch of traffic on port 22, most likely. So let's have a look at this. We'll say TCP port equals 22. And we see that there is still quite a bit of traffic. In fact, almost all of the traffic is still here. There's an awful lot going on port 22 by people that have logged in via SSH. And of course, it's all encrypted. So knowing exactly what's happening here is a little bit difficult. You can't exactly just unencrypt all of this. What about our dropbear? We had a dropbear backdoor installed. Let's see if we found any traffic for that. That was on port 44965. And sure enough, we can see a test of this dropbear backdoor. So here we can see that coming in from the .1 machine, which again, since this was run in a virtual machine, is where all the traffic's going to come from. We have a connection, and then we have responses, connection, responses. We look into this packet, we should be able to see some of the metadata and also able to see the actual data itself that was transmitted. Now, if we go and look at some other items, we should be able to figure out the actual calendar time of this test. And going through the file system and looking at what's going on there and going through other system logs, I was able to determine that this happened on May 4th. So the day after the main breach occurred on May 3rd was when this test was performed. We see some web traffic here. You might ask yourself if any of this is malicious web traffic. You would have to look into the actual packets in order to get a feel for that. So if we examine some of this web traffic, or what appears to be web traffic, we should be able to see some standard requests being sent, if in fact this is legitimate web traffic. And that doesn't seem to be what we're getting. This might make you somewhat suspicious that someone is using one of these backdoors that were installed. So let's have a look and say, what if we want to look at all the traffic that was not port 80 and not 22 and not 44965. Let's see if there's anything left. And we do have some traffic left. So we see that there is a little bit of traffic that is using HTTPS POP3, which is kind of interesting. This one is using a port of 8080, so there might be something to look at there as well. The MySQL traffic, IMAP traffic. So it looks like there's actually quite a bit of traffic that you wouldn't necessarily expect on this domain. Now, one thing you'll note is what is this traffic? This traffic here appears to be part of a port scan that was performed from that machine to the .1 machine. So someone on the subject system tried to probe back. Again, this could be an indication of an attacker who is running an Nmap scan. Here we see an FTP connection being made and another apparent port scan. So let's have a look at FTP connections as well. We'll go ahead and clear this, and we'll look here, TCP port == 21. We'll see if there was any significant FTP traffic, and apparently there was not, at least not in this packet capture. Now remember what we said before in a previous video. There's evidence that the attacker ran Hydra against FTP on the local host. Notice that this packet capture doesn't capture any of that traffic. So that's a smart move on the attacker's part in order to avoid detection. Since they've already gotten onto the system, their foot's in the door, so to speak, they can then use that, try to gain some further access and get deeper and deeper into the system. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello, everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue our investigation of the PAS2 subject system. In particular, we're going to have a look at some of the login information that was captured. So we've used the techniques that we described in previous videos in order to import a lot of this metadata information from the files, logins, and logs into MySQL. And now we're going to have a look at some of that information and see if we can determine any other data, if we can find any more evidence to further nail down exactly what happened. So I'm going to go ahead and log in to MySQL. I'm going to connect to my database. I can do a show tables. And you can see I have my file metadata, my groups, my users, my timeline, my logs, my histories, and I also have my logins and login fails. So let's start with the logins. If I do a select star from logins, order by start, this will give me a list of successful login onto the system. Now, if I back up, I will see that on May 3rd, the system was rebooted. I see that John was logged in. System was rebooted again. John was logged in a couple of times. And then on May 4th, we see some more logins by John. And something new, we see a login by Michael. So we can see there was a little bit of activity on that date. So by itself, this is not suspicious. Let's have a look at the login failures. Select star from login fails, order by start. So now we see something interesting. Notice that there is a large number of failed login attempts on May 3rd at 23:07 for the John user. Then there's a gap and there's a couple of failed logins for John later. It's interesting that there are so many in such a short time period. That normally would indicate some sort of automated attack. So if we go back and we say, okay, this is 23:07, let me go back and look at my logins. So here at 23:10, I have a successful login, and there's no activity for quite a while with the John user. So what does that tell me? That tells me that they correctly got John's password. Otherwise, they wouldn't have had a successful login here, and they wouldn't have given up. What this means is someone needs to talk to John about password security, because his password is obviously weak if it was cracked so quickly. So we can see that, in fact, his password was used. Now, we don't really know about this login from Michael. This could be a legit login. Perhaps his password was hacked. We really don't know. The other thing that we don't know is that Sue's password was attacked using FTP. It does not appear as though Sue ever logged on to the system, but that doesn't necessarily mean that the password attack against her was successful. It could be that they used FTP or some other means to access the system. They might just be holding on to that password as well to use in the future. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon.